In the previous video, we learned about the formation of the Earth and Moon and that there were rains that lasted for countless centuries. In this video, we explore more about what the Earth will change to have the first sprouts of life. Let's get started. Part 2: the Archean Eon, 4.0-2.5 billion years ago. The beginning of a NEW world by approximately 4.0 billion years ago. Earth had changed dramatically. The endless asteroid bombardments that had once devastated the planet became far less frequent. Volcanic activity remained intense, but the surface had cooled enough for vast oceans to exist. For the first time in Earth's history, liquid water covered much of the planet. According to the International Commission on Stratigraphy, this marked the beginning of the Archean Eon, which lasted from 4.0 billion to 2.5 billion years ago. Although the Archean Earth was still hostile compared to today, it represented a crucial turning point. For the first time, conditions suitable for life may have existed. No forests, no animals, no dinosaurs, no humans. Only oceans, volcanic islands, and a sky unlike anything we would recognize today. The first continents during the Hadean Eon, Earth's crust was thin and unstable. But throughout the Archean, the planet continued to cool. The crust gradually thickened. Molten rock solidified into the first stable continental fragments, known as cratons. Many of these ancient rocks still exist today. Some of the oldest exposed rocks on Earth can be found in Western Australia, Canada, Greenland, and South Africa. Several formations are over 3.8 billion years old. According to the USGS, these rocks provide invaluable evidence of Earth's earliest geological history. Unlike modern continents, the first landmasses were relatively small. They resembled chains of volcanic islands rising above vast oceans. Over hundreds of millions of years, plate tectonics slowly pushed these fragments together. This marked the beginning of the continents we know today. A different atmosphere. If you could travel back to the Archean Earth, you would not survive for even a few seconds. The atmosphere contained almost no breathable oxygen. Instead, it consisted mainly of nitrogen, carbon dioxide, methane, and water vapor. Because oxygen was nearly absent, there was also no protective ozone layer. Powerful ultraviolet radiation from the sun reached Earth's surface almost unhindered. Fortunately, much of the earliest life developed beneath the oceans, where water acted as a natural shield against harmful radiation. Scientists believe that these underwater environments provided a safe refuge for the first living organisms. How did life begin? One of the greatest mysteries in science remains the origin of life itself. Exactly how non-living chemicals transformed into living cells is still unknown. However, several scientific hypotheses attempt to explain this remarkable transition. One of the leading ideas suggests that life began in the oceans. In shallow coastal waters, lightning, volcanic heat, and ultraviolet radiation may have driven chemical reactions between simple molecules. Over millions of years, increasingly complex organic compounds formed. Eventually, these compounds assembled into microscopic structures capable of storing information and reproducing. Another leading hypothesis points to hydrothermal vents deep beneath the ocean floor. These underwater volcanic systems release hot, mineral-rich fluids into surrounding seawater. According to research published by the Smithsonian Institution, hydrothermal vents contain abundant chemical energy that could have powered the earliest life. Even today, these vents support unique ecosystems that thrive without sunlight. Regardless of where life first appeared, scientists agree on one remarkable fact. Life emerged surprisingly early in Earth's history. The first living organisms, the earliest organisms, were incredibly simple. They consisted of single cells lacking a nucleus. Scientists classify them as prokaryotes. These tiny microorganisms were the ancestors of all life on Earth. Unlike plants and animals today, they did not require oxygen. Instead, they obtained energy through chemical reactions involving sulfur, iron, methane, or other compounds found in the ancient oceans. Although invisible to the naked eye, these microbes transformed the planet forever. Without them, complex life would never have evolved. According to geological evidence, some of the oldest fossilized microbial structures are approximately 3.5 billion years old. These fossils were discovered in Western Australia and remain among the strongest pieces of evidence for Earth's earliest life. Stromatolites, Earth's oldest fossils, one of the most important discoveries supporting early life, comes from unusual rock formations known as stromatolites. These layered structures are created by colonies of microorganisms that trap sediments while growing. Some living stromatolites still exist today in places such as Shark Bay, Australia. Modern examples closely resemble fossils dating back more than 3.4 billion years. According to the Smithsonian Institution, stromatolites represent some of the oldest direct evidence of life anywhere on Earth. Although they appear simple, these microbial communities would eventually reshape the entire atmosphere of our planet. The great invention, photosynthesis, perhaps the most revolutionary biological innovation in Earth's history, occurred during the Archean Eon. A group of microorganisms known as cyanobacteria evolved the ability to perform photosynthesis. Instead of relying solely on chemical energy, these microbes began using sunlight. They absorbed carbon dioxide and water to produce food. As a byproduct, they released oxygen. At first, this oxygen did not accumulate in the atmosphere. Instead, it reacted with enormous amounts of dissolved iron in the oceans. This reaction formed vast deposits of iron oxide that eventually settled onto the seafloor. Today, many of the world's largest iron ore deposits originated during this process. For millions of years, cyanobacteria continued producing oxygen. Little by little, the chemistry of Earth began to change, without realizing it. These microscopic organisms were preparing the planet for a future filled with forests, dinosaurs, mammals, and eventually humans. The end of the Archean Eon, by 2.5 billion years ago, Earth looked very different from the world that existed at the beginning of the Archean. Stable continents had formed, the oceans were filled with microscopic life. Photosynthetic bacteria had begun producing oxygen on an enormous scale. Although the atmosphere still contained very little oxygen, an invisible transformation was already underway. That transformation would soon trigger one of the greatest environmental revolutions in planetary history. In the next chapter, we enter the Proterozoic Eon, where oxygen would forever change Earth's atmosphere. The planet would experience global ice ages, and the first complex multicellular organisms would finally appear.